Hello student, welcome and very good morning to you. Today I will be discussing the DPP on types and representation of error, that is DPP 6. I have already uploaded the 5 DPP of units and measurement. So these DPPs are extremely helpful to those students who are preparing for NEET, main, advanced and WB joint. Okay, please write a comment on the video because this comment will be extremely helpful for me to make better video for you. Okay, now let's start. Now first of all, absolute error. The positive value of error is called absolute error. Okay, now a relative error. Relative error is delta r by r is equal to relative error. If relative error is expressed in percentage, it is called percentage error. So percentage error is equal to, this is the delta r by r percentage. Now addition and subtraction of error. If a equal to x plus y, then absolute error of a is equal to absolute error of x plus absolute error of y. If b equal to x minus y, then absolute error of b is equal to absolute error of x plus absolute error of y. In the same way, look at this. If c equal to x into y, so here relative error of c equals to relative error of x plus relative error of y. In the same way, the d equal to, this is the k x by y. So here relative error of d equals to relative error of x plus relative error of y. Now, if e equal to, this is the k x to the power n, then delta e by e, this equals to n into delta x by x. Okay, these are the formula which are helpful to solve this problem. Now, question number 1. The length of a rod is 11.05 plus minus 0.05 centimeter. What is the sum of lengths of two rods? So look at this. To multiply this by 2, we can get, look at this, this is the 22.10 plus, now look at this, 0.05 plus 0.05. So this is the plus minus 0.10. Look at the options. Look at this. 4 is the correct option. Now, question number 2. The resistance are equal to V by I. V given, I given. What is the total error in R? So we have to express the percentage error of R. Now, it is the formula for division. Look at this. Here, relative error of R equals to relative error of V plus relative error of I. No problem. So look at this here, delta V is equal to 5, V equal to 100. So look at this, this is the 5 by 100 plus, look at this is the delta I equals to 0.2 and I equals to 10. Okay, so look at this 100 LCM. So look at this is the 5 plus 2. So this is the 7 by 100. Therefore, 7 by 100 into 100%. So look at this is the 7%. So look at this, option 2 is correct. Now look at this. When a copper sphere is heated, the maximum percentage change will be observed. Look at this. If delta R by R is the relative error of radius, then delta A by A, this equals to 2 into delta R by R. And relative error of volume V equal to, this is the 3 into delta R by R. So look at this, maximum percentage error is 3 times the percentage error of radius. So volume has maximum percentage of error. Option 3 is correct. Okay. Now question number 4. If error in measuring the diameter of a circle is 2%, the error in the circumference of the circle will be. If d be the diameter of a circle, then circumference S equals to, this is the pi into d. Here delta d by d, this equal to 2% is given. We have to calculate circumference delta S by S. Okay. So look at this. Here delta S by S, this equals to delta d by d. So look at this. This is the 2%. Okay. So percentage error in the circumference of the circle, this is the only 2%. Okay. Next. Now, question number 5. The error in measurement of volume of a sphere is 1.5%. The error in measurement of its diameter is. Okay. Now look at this. If V be the volume and D be the diameter of a sphere, then 4/3 pi into D by 2, D is the diameter whole cube. So look at this. This is the 1 by 6 pi d cube. Okay. Therefore, relative error of volume delta V by V equals to, look at this. This is the constant. So this is the 3 delta d by d. Here delta d by d will be calculated. Now delta V by V is given. So look at this. This is the 1.5%. This equals to 3 into delta d by d. So look at this. Here delta d by d, this equal to, this is the 1.5 by 3. So this is the 0.5%. What is the answer? Look at this. Option 3 is correct. Okay. Now question number 6. There is an error of 2% in the measurement of side of a cube. Look at this. If x be the side of a cube, then delta x by x, this equal to 2%. No problem. Percentage error in the calculation of volume. If x be the side, then volume V equal to, this is the x cube of a cube. So relative error of volume, this equals to, this is the 3 times the relative error of side. Here delta x by x is the 2%. So look at this, 3 into 2%, therefore 6% is the percentage change in volume. Look at this, option 4 is correct. Okay. Look at this, question number 7. If a thin copper wire of length L meter increases in length by 2%, that is delta L by L, this equal to 2%. No problem. When heated to 10 degrees Celsius, what is the percentage increase in area? Okay. Percentage increase in area when a square of copper sheet of length L meter is heated through 10 degrees Celsius. So look at this. Here S is equal to L square, area of the square sheet. So look at this. Here area delta S by S, this equals to 2 times delta L by L. So look at this. This is the 2 into 2%. So look at this. This is the 4%. Okay. Look at this. Option 1 is correct. Now question number 8. The percentage error in the measurement of mass and speed are 2% and 3%. Look at this. Here delta m by m, this equal to 2%. And if v be the speed, then delta v by v, this is the 3%. Okay. How much will be the maximum error in the estimate of kinetic energy? If k be the kinetic energy, then delta k by k is the question mark. Okay. Now look at this, k equal to, this is the half mv square. Half is constant. Therefore, this is the delta k by k. This equals to delta m by m plus 2 into delta v by v. So look at this. This is the 2% plus 2 into, this is the 3%. Okay. So look at this. This is the 8% is the percentage increase of kinetic energy. Look at this, option 2 is correct. Now question number 9. The initial and final temperature of water as recorded by the observer is 40.6 plus minus zero point 0.2 degrees Celsius and 78.3 plus minus zero point 0.3 degrees Celsius. Calculate the rise in temperature of the error limit. Look at this. So, change of temperature, this is the 78.3 plus minus 0.3 degrees Celsius. Okay, minus this is the 40.6 plus minus 0.2 degrees Celsius. So look at this 78.3 minus 48.6. So look at this is the 37.7. And look at this minus this. In error calculation, this and this are added. So look at this is the 0.5 degrees Celsius. So look at this is the 37.7.5 degrees Celsius. Okay, option 3 correct. Now look at this question number 10. If A equal to 8 plus minus 0.08, B equal to this, x equals to a plus b, y equal to a minus b, z equals to ab. Therefore, correct order of percentage error in x, y, z. Now look at this delta x by x. So this is the delta a by delta a plus delta b divided by a plus b. Okay. Now delta a equal to 0.08, delta b equal to 0.06. So look at this is the 0.1 and 8 plus 6, this is the 14. So look at this 14 and this is the percentage error. So 100 is multiplied. So look at this is the just 1%. Okay, now y. Delta y by y, look at this, y equal to a minus b. So delta y equal to, this is the delta a plus delta b. So look at this here, delta A plus delta B, that is 0.08 plus 0.06 divided by 8 minus 6 into 100%. So look at this is the 0.14 by this is the 2 into 100%. So look at this is the 7%. Now Z equal to AB. Therefore, relative error of Z, this equals to relative error of A, that is delta A by A plus delta B by B. Now, what is delta A by A? Look at this delta A by A 0.08 by 8 into 100%. Now, delta B by B, look at this delta B by B, this is the 0.06 divided by 6, okay, into 100%. So look at this is the 1%. So error in measurement of A is 1%, error in measurement of B is the 1%. So look at this 1% plus 1%. So look at this is the 2%. So maximum error in Y, then Z, then X. So look at this X less than Z less than Y. Option 3. Many thanks for watching this video. This video will be extremely helpful in your preparation for NEET, main, advanced as well as West Bengal joint. Okay. Thank you.